Hello everyone. Today I am going to be talking you through how to complete a PSMT in the Queensland Maths syllabus. A PSMT stands for Problem Solving and Modelling Task, okay, otherwise known as a maths assignment. So if you think of a PSMT being held up by two pillars, there are two main things that we need to consider when tackling one of these PSMTs. And the first thing is your context. What is the assignment about? And a part of that is the content that you are learning. Okay, now I can't really help you with this on a specific level because every PSMT is going to look and sound different, okay, depending on what subject you're doing and what content it's based on, and even the same content can have many different contexts. So my first piece of advice for you to do your PSMT is make sure you know what you're doing in terms of the content. Okay, once you've got that nailed, then make sure you fully understand the context of your assignment, okay? So I can't specifically help you with that, but what I can help you with is the format that the PSMT takes, okay? There's a very specific way of addressing these PSMTs. There's very specific language that you need to use, sort of key things that you need to tick off, okay? So that's what we are going to learn about today, the format. Now, the easiest way for me to do that is to make this part, the context and the content, as easy as possible, okay? Because one of the difficulties of a PSMT is that you're balancing these two very heavy pillars. You have to understand the format, and you also have to understand some quite difficult maths. Okay, so if I make this pillar as easy as possible, then we can just focus on learning the format. Okay, so that's what I'm trying to do today. Okay, so I'm going to take you through the 4-stage process of a PSMT, and I'm also going to take you through the criterion and how to mark a PSMT, what your teacher might be looking for when they're marking your PSMT. And what I'm going to do is get you to do stages of this as we go along so that you can self-assess. Okay, so have pen and paper ready so that you can participate. Would even be great if you could do this with a friend nearby so that you can critique each other's work. Okay, so here is our 4-step process for doing a PSMT. Stage 1 is formulate. Once you've got your plan ready to go, you move into solve. Stage 3, evaluate and verify, and stage 4 is to communicate your solution. And you'll notice there's these little feedback loops happening here, so if something goes wrong at any stage, you go back to the top and start again, okay? So I'm going to talk you through this in a lot more detail now. First of all, I have a wall of text, okay? But what I have here is the information from the syllabus about the 4 stages, okay? So what you can do is pause the video and have a read of this. I don't want to read out every word to you. And you can see in more detail what they're looking for. Okay, so very briefly, stage 1 is about mathematizing a problem. It is about turning, so mathematization is that key word there. It's about taking a real world situation and turning it into some maths. Okay, now we call that modeling in maths. And when I say modeling, don't picture someone walking down a catwalk. I want you to think about putting a real life situation into the context of some maths that we've been doing, okay? But stage 1 is mostly about coming up with a plan to address a problem that you've been given, okay? Once you have your plan ready to go, you can move on to stage 2. Once again, you can pause the video now and have a read of that section. But in short, solve is just about attempting to come up with a solution to the problem as best you can using technology and your other mathematical techniques. Okay, once you have reached a solution, you can move on to stage 3. If your solution was not great, you can always go back to step 1, back to the drawing board, try again. Okay? Stage 3 is where you evaluate your solution and verify it. Okay? Feel free to pause the video and read that now. But in short, evaluating is about making a judgment about your solution, okay? And we're going to talk in more detail about what that means later on when we actually try it for ourselves. Stage 4 is then to communicate your answer. Now, I find that most students doing a PSMT will actually be doing stage 4 as they go along, okay? A lot of students, I find, they start typing things up as they're getting their ideas. So you're kind of constructing your report as you're completing it, okay? I think when the authors had this, when they were writing this, they kind of expected someone to be doing everything with pen and paper, having a eureka moment, and then getting out their computer and typing it all up. But in the real world, I find most students are writing their report as they go along. So you might find that stage 4 is happening throughout the whole process. Okay? So here's my super easy example that hopefully everyone will be able to do the maths for this one, okay? It's really just about estimating, okay? So here's my example of a super easy PSMT. A teacher has asked you to estimate how many steps it will take for them to walk from the classroom to the hall, okay? That's the question you've been given, the problem you need to find a solution to. Nice and easy. Okay, so let's start at stage 1, formulate. Okay, I want you to come up with a plan to solve this problem. What mathematical concept or techniques are you going to use? Make sure you outline that. What is the key terminology involved? If you need to define anything, that's the time to do it. And I want you to think about what technology you might use. Okay, so I would like you now to quickly write down, pause the video, get out your pen and paper, write down how you would tackle this question, okay, with solving this question that you've been given, okay? And then once you've written your answer, we're going to have a look at the criterion and my exemplar and see how you fared. Okay, so pause the video, have a go. Okay, so assuming that you have done that, let's have a look at what the Formulate criterion looks like. Now, here it is, Formulate. We have 3 assessment objectives here, okay? And these are what we would call the descriptors. This is the high-level descriptor, the mid-level descriptor, low-level descriptor, okay? Now, the dot point I want you to look at right now is actually the 3rd dot point in each level, okay? So have a look at this dot point and this dot point. And of course, this one just means that you didn't manage to do it at all, okay? So I want you to have a look at what you've written and ask yourself, have you accurately translated all aspects of the problem by identifying mathematical concepts and techniques? Now, obviously, in this case, this is a very simple problem, so this criteria might apply more, but hopefully you understand that in a harder situation, this would be needed in more detail, okay? So let's have a look at what I wrote. Here's my example. To answer this question, I have decided to walk the path myself and count my steps. The mathematical concept involved is simple measurement and arithmetic, and I would add estimating in there as well. And perhaps you might define estimating, okay? You might think about what technology you would use. I'm not going to go into too much detail into that right now because this example is so simple we don't really need a lot of technology. But hint, most of the technology you would be using is either the program Excel or the program Desmos. Those are the ones that we tend to use the most in these PSMTs, okay? So get familiar with those is my hot tip there. Make sure you know how to use Excel and make sure you know how to use Desmos and all of its functions. Okay, so now that we've looked at that 3rd dot point there, we're actually going to go back to the other 2. I'm not really sure why that one's the third one listed, because I personally would think it would be best to outline my plan first before I talk about assumptions and observations. But I also understand if you might want to do a little introduction, talk about observations and assumptions, and then come back and in more detail outline what you're going to do. Okay, it doesn't really matter as long as you have an introduction, body, and conclusion. We're going to talk about that later, and subheadings. It doesn't matter what order in particular you do this in. Okay, but that's my example. This is our plan of attack so far, to walk the path and count the steps myself. Now, assuming that we're going to go with my plan here, speaking of assuming, I would like you to list any observations and assumptions that you are making. Okay, now your first question might be, what's an observation and what's an assumption? And then your third question might be, what's the difference between them? Well, I have you sorted here. Assumptions are conditions that are stated to be true when beginning to solve a problem, and observations are information or data that is required to solve the problem. Okay, so observations is the information that you need to gather first. The assumptions are certain conditions that you have to accept in order to solve the problem. Okay, I'm going to give you some examples, but first I'd like you to give it a go of coming up with some answers yourself. Okay, pause the video, and I'd like you to write your assumptions and your observations. Okay, now I want you to look at that criterion again. Okay, have a look at the difference between the high and mid-level criterion for assumptions. Okay, and you see there's two main differences: documentation versus statement, and then appropriate assumptions is in the top one. Okay, so obviously if you don't address all the best assumptions, all the really important ones, then you're not going to get that high level descriptor. Okay, and the other big difference is documentation versus statements. Okay, you will also see assumptions is plural there. You need to do more than one. Okay, so have a look at the difference between the high and mid descriptor for observations now. What are the differences? And you'll see once again we've got this documentation versus statement thing. And of course the high level also has accurate, meaning the information has to be correct, and relevant, meaning it has to be important for the assignment. Don't include details that are extraneous. We don't need that. Okay? But once again, we've got this difference between documentation and statements. Okay? Now, you might be wondering, what is the difference between those two things? Okay? Now, the best way to explain it to you is we need elaborations. Okay? So to get those mid-level assumptions, you might end up with just some dot points like this. Okay? Here are the assumptions that I wrote down at first. My first assumption is that my step size is the same as the teacher's step size. Maybe you wrote that one. Give it a tick if you did. The next assumption I made is that they take the same route as me. If they don't, might be a problem. And then the next one, that they go directly to the hall and don't go to their desk or somewhere else first. Okay, that's another assumption I'm making in order to solve the problem. I just have to assume that these three things are true. They might not be. We'll get to that later. Okay, but this is what I would call statements. Okay, these are sitting, wrong one, here. Statements of assumptions. What turns them into documentation, you might wonder? Well, you need to elaborate further. Okay, so what I want you to do now, if you haven't already done so, take these three assumptions and I would like you to explain to me why you need to make these assumptions. Okay, what happens if this assumption is correct? What happens if this assumption is not correct? Okay, why did you have to make this assumption in the first place? Okay, so I'd like you to pause the video and have a go at that, and then I'll show you my example. Okay, so those are my mid-level assumptions. Let's have a look at what those same assumptions at a high level look like. Same 3 dot points, but I've elaborated further. So I've written, to answer this problem, I assumed that my step size is the same as the teacher's step size. If my step size is even 1 centimetre larger or smaller than the teacher's, this could result in a significant difference to the number of steps over a large distance. This would have a less of an impact over a short distance. Okay, so hopefully you can see the difference between the 1 sentence dot point I made here and the much longer elaboration that I made here. I've explained why I need to make that assumption and what's the impact of that assumption on my solution. Let's do the next one. I also assumed that the teacher takes the same route as me. See observation for route details. We'll talk about that in a second. If the teacher takes one of the shortcuts, like using the elevator or going through the library, this would result in less steps. Okay, so you can see my much further elaboration compared to the second dot point there. And then my third one, I assumed that the teacher will go directly to the hall and didn't go to their desk or somewhere else first. If the teacher does take a direct route, then my solution should be fairly accurate. If the teacher doesn't take a direct route, this would result in more steps to get to the hall and my answer would be less accurate. Okay, so hopefully now we can see the difference between statements of assumptions and documentation of assumptions. Okay, so give yourself a grade. Where would you mark yourself on your original answer? And hopefully you can realize how to take it to the higher level. Okay, so just to sum up and copy this down if you would like, assumptions must be documented. Explain why you needed to make this assumption and the impact that it may have on your solution. Explain what might happen if your assumption turns out not to be correct. This might help you when we get to stage 3. Now, I've also made some sentence starters for you. I've sort of divided them into 2 parts. You would do this bit first, fill in the blanks, and then you'd follow up with one of these sentences. Okay, so you might start with, I assumed that. Now, it is perfectly permissible for you to write in first person on a PSMT, so you are welcome to say, I assumed that. However, if writing in first person is really uncomfortable for you and you would like to write in that scientific third person passive voice, you can change that to, it was assumed that, or you could write, one assumption that was made was blah, blah, blah. Okay, so fill in what your assumption would be. Then you need to follow it up with one of the next sentences. You could say, this is relevant to the model because blah, blah, blah. The impact that this will have is blah, blah, blah. This is important because blah, blah, blah. If this assumption is true, then this will be the impact. If this assumption is not true, then this will be the impact. Okay, so those are some sentence starters if you get a bit stuck. Okay, so your sort of first dot point will be stating what the assumption is, and then this sort of second section here is elaborating, explaining the rest of your assumption and the impact it will have. Okay, last bit for the formulate stage is your observations. So I'd like you to pause the video and write down what data or information you think you might need in order to solve this problem. Okay, so I would just like to remind you after you've written them down, you must document your observations as well. So if you haven't done that, pause the video, try again. Okay, let's have a look at some mid-level observations. Remember, these are going to be statements. So first of all is information about the route that I took. I will go down the stairs near the end of A block, then walk past the courtyard along the oval to the hall. Okay, obviously I'm speaking very generically there. You would be more specific according to your context. And then the other information that I've included is my step size. I've said that my average step size is 60 centimetres because we did mention that this might be relevant in our assumptions. So I've included it in my observations. Now, hopefully you can clearly see that those are just statements, and so that makes them mid-level. Let's have a look at what these observations look like at a high level. Hopefully you can see again that I have elaborated and explained my observations. So I've written, firstly, I needed to gather some information about the most likely route that the teacher could take. This is important to the solution, as discussed in the assumption section, since this would affect the number of steps taken. I decided on the following route. I will go down the stairs, blah, 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 blah. Okay? The next, I needed to measure my average step size. As discussed in the assumption section, I may need to compare my average step size to the teacher's average step size, since this would also affect the number of steps taken. My average foot size is 60 centimeters from the back of the heel to the back of the back foot to the front toe of the front foot. Okay, so you can see I've added more detail there, making it more accurate, and I have explained and elaborated, thus documenting my observations. Okay, so to sum up there, observations must be documented, and here's some ways you could do that. You could do an explanation about their relevance to the model. You could also use some in-text referencing. You could also use a screenshot from the website. Okay, there's lots of different data or information you might need to gather. So make sure you've done that. Okay, so that moves us to stage 2, which is solve. And I've just made this bit up for you. This bit's a bit harder to actually show you because, of course, we are doing a very simple version of a PSMT, just trying to understand the format and the language used. Okay, so I'll just talk you through this section. Okay, so in this very easy example, I just came up with a solution and I got 179 steps. Lovely. Now, if you were doing one of these for real, okay, have a look at the assessment objectives for solve and let's have a look at the descriptors. Okay, let's have a look at the first dot point. The first dot point, this one, this one, this one, okay, we have 3 levels here. There's a lot of marks that can be allocated in the solve section. You'll notice between this one and this one, it still says complex procedures, and it's not until we get down here that we are using simple procedures to reach a solution. Okay, so hopefully you can see from that it's really important that you do build some complexity into your answer. Okay, that you use some complex procedures in some way. Okay, that doesn't mean that your PSMT has to be impossibly difficult. It also does not mean that you go beyond the scope of your content. Okay, do not go beyond what is on the syllabus. Okay, in fact, that will be detrimental to your mark. Okay, but you do need to build some complexity into it in some way. Okay, let's look at the difference now between the very top one and the next one down. They both use complex procedures, but you'll notice the second one here is what happens if you make a small mistake. Okay, because what's changed is accurate is now gone, and instead of a valid solution, you have a reasonable solution. So if you make a mistake in some way, but you still reach a reasonable solution, and you've still used complex procedures, perhaps incorrectly though, then you'll land yourself at this second level here. Okay, that's the difference between those 3. Now, the next dot point down, let's have a look at these 3 here. The top one is discerning application of mathematical concepts and techniques relevant to the task, okay? So discerning means that you pick and choose the best strategies, okay? Only the best. John West only accepts the best, okay? We only have those really effective techniques, okay? So if you've done something where you still get a good solution, but you've done it in a really convoluted way, then you might see yourself getting the next level down, okay? And of course, if you haven't built any complexity into your solution, then you're going to end up at simplistic application, okay? Now, the third one is use of technology, okay? So for the lowest one, we've got superficial use of technology. That's the sort of mark you're going to get if you're only using word processing and your calculator, perhaps. Okay, to get beyond that, that's where you have to use things like Excel or Desmos to get use of technology. And accurate and appropriate use of technology is where you use it to the full extent, you're using the correct formulas, you're getting the answer out well. Okay, I would highly recommend, if you're using Excel to get that top level descriptor, that you use dependent formulas in some way. Okay, so make sure that you use formulas. You're not just using Excel to tabulate information, you're actually using the formulas to do the calculations for you, and that if you change variables, they will continue to change further down your page, okay, and adapt like that. Okay, so that's my advice for the solve section. Okay, make sure your technology use is correct and appropriate. Now, my last little hot tip that I've added down the bottom here is make sure that you actually state your solution at the bottom of this section. Okay, I see sometimes students wait all the way to the conclusion to actually say what the solution to their problem is. This is not advised, okay? You should say in this stage 2 what your solution is, because we will get to stage 3 and you'll see why you need to do that. Okay? Moving on to stage 3, evaluate and verify. So this section is probably one of the trickiest ones to get your head around, okay? Because we're not always used to doing this process in maths. Often in maths, we get the right answer and it's either right or it's wrong. If it's wrong, we correct it and then we move on, okay? But this is a little bit more complex than that. So let's have a quick read. Once a possible solution has been achieved, students need to consider the reasonableness of the solution. Okay, how reasonable is it? Is it valid or is it not? We need to consider the strength and the limitations of the solutions. Where necessary, this will require going back through the process to further refine the solution or to verify the solution with a different method or with a different source. Maybe you need to check the research and see if somebody else has done something similar. Okay. This stage emphasizes that problem solving is not usually linear and involves an iterative process. Now, that's a weird phrase, but what that means is often when you're solving a big maths problem, you might find that there are lots of iterations to your solution. You try something, it doesn't quite work out, so you try something different. Maybe you just build on what you did in the first go. Okay, but you might see that there's lots of iterations, and that is very normal in a maths problem-solving context, okay? It's also important that you show that iterative process, okay? Sometimes I see really particularly high-achieving students that just give me the perfect answer first go. And what they've done is they've hidden all the work that happened behind the scenes because they don't want people to see that they got things wrong. Okay, you do actually have to show me the process, the journey you went on, okay, so that we can see that you have made refinement to your model. Okay, now, just a little note here, you don't have to refine or extend your solution or verify with a different method, but it is the best way to make sure that you are addressing the high-level descriptors in this criterion. Okay, so I would highly recommend that you do something. You either extend your solution in some way, you refine it in some way to make it better, or you verify it with a different method or a different source of information. Okay, I would highly recommend you do that, because it's going to get you the best bang for your buck. Okay, so what I would like you to do now is to think about the solution we got, which I gave you, which was 179 steps. Think about some of the assumptions we made and think about how we could reflect on our solution, on our plan for solving this problem. What could we do better? How could it potentially have gone wrong? And what way could we extend or refine it in some way? So pause the video, write down your answer, and then I'll show you mine. Okay, so here's what I have written. My solution of 179 steps is a reasonable estimation due to the accurate way that the information was gathered and the reasonable assumptions made. However, to verify my solution, I followed my teacher as she walked to the hall for assembly, with permission of course, and I counted her steps. I found that I had overestimated by 34 steps. Okay, so that's me reflecting on my solution and evaluating it. Okay, I've made a judgment about my solution and I've said that it is fairly reasonable and accurate. Okay, and I've explained why. But let's talk about the strengths first of my model. Now, a lot of students struggle with this section. Okay, because we need to understand the difference between something that is correct and something that is right. Okay, there is a difference. Okay, correct means free from error, and right means the opposite of wrong. And we have to understand about mathematical models that they are built on the correct mathematics. They're free from error, but they are often wrong. Okay, so there's this famous quote here by George E.P. Box that says, all models are wrong, but some are useful. Okay, when we try and turn a real life situation into maths, we try and mathematize it, we're always going to lose some nuance. Okay, something is always going to be overestimated or underestimated, so it's always going to be wrong. It can still be correct because we did the maths correctly, but it is going to inherently be wrong. Okay, so instead of asking yourself, is my model right? I want you to ask yourself, does my model fulfill its intended purpose? Okay, so I want you to try and write a little paragraph about the strengths of your model, answering that question. Pause the video, have a go, and then I'll show you my example. Okay, so here is my answer to this section. I wrote, this mathematical model allowed me to better understand a real-world phenomena which has multiple areas of application. It also allowed me to make predictions, estimate a reasonable and valid solution, and therefore answer the question proposed. Now, based on your context for your PSMT, that's going to need a lot more detail, specifically about what you're doing. This might also be a good time if you have two alternative methods to talk about the strengths of each method compared to the other. Okay, but here's a good sort of generic starting point for talking about the strengths of the model. Once again, accuracy, correct, free from error, we're happy with that, but also, is it useful? Okay, and in what way is it useful? Let's talk about limitations now. Okay, now for limitations, I want you to think, did you have to leave out or ignore anything? Maybe because it was out of the scope of your assignment, maybe you needed information beyond what you're learning about in this course. Could improvements be made to this model to make it more accurate? You could revisit your initial assumptions and observations and refine these if necessary, accommodating any unexpected findings. Okay, so I want you to pause the video now. I'd like you to have a go at writing down any limitations you think there might be to our method. Okay, let's have a look at my answer now. I wrote, I had overestimated the number of steps because some assumptions turned out not to be true. For example, my step size is not the same as the teacher's. Her step size is slightly larger, and this meant that she took less steps to get to the hall. Additionally, the route that I decided to take was not the same route that the teacher decided to take. The teacher took a different set of stairs. However, there is only a difference of 3 stairs, so this did not have a large impact on the result. Okay, so that was my answer. You might have written something different. We're going to have a look at the criterion in a minute, and you can self-assess there. The last thing you need to do is make sure that you justify all decisions made about procedures by explaining your mathematical reasoning. This might be happening as you go through the report. I would find most students justify all the way from Formulate, where they're outlining their plan and justifying those decisions as they go along, but it might not be a bad idea to sum that up in a section in part 3 here. Just go over all the decisions you made, why you made them, explain what you were thinking, okay? Now let's have a look at the criterion, okay? And once again, you're seeing these words here, statement, statement, statements, okay? Statements and dot points are only going to give you mid-level, okay? You'll see high level needs much more explanation, elaboration, etc. So let's have a look at the first one. Evaluation of the reasonableness of solutions by considering the results, assumptions, and observations. Did you see me do that up here? Yes, I did. Okay, I reflected on the assumptions and observations made, and I explained all that. Okay. Documentation of the relevant strengths and limitations. Notice plural. You need more than one. Okay. And remember, you should know by now the difference between a statement and the difference between documentation. Okay. And hopefully you can see evidence of that in my responses as well as in your response. And then the last dot point, justification of decisions made by using mathematical reasoning. As I said, you have to explain things as you go along. You have to tell me why you've chosen those things. Reasoning, what were you thinking? Okay, so that's the main difference there. Then we'll briefly talk about stage 4. Like I said, you've probably been doing this all along as you've been typing up your report as you go along. Let me just give you some pointers here. Make sure you use the correct terminology and notation, okay? Would highly recommend that you find the glossary for whatever topic your PSMT is on, okay? And use those words, okay? If you don't use the correct terminology and notation, you will find yourself struggling to make the high-level criterion, okay? It's really important that you use the correct terminology in the correct way. I find that students go a bit awry with this when they try and get clever with a thesaurus, okay? Mathematics has very precise language, and if you try and use your thesaurus to use other words, you will find that it doesn't make sense anymore, okay? That's why it's important to be familiar with the content before you start. Next one, make sure you write clearly and concisely. Okay, write clearly, use short sentences. You don't need to write a paragraph that is all one sentence, okay? Also concisely. Do not waffle on. You only have a limited word limit. You only have a limited page limit, okay? So make sure you're not waffling. Use concise language. Make sure you have an introduction, body, and conclusion, okay? And label them if you need to. Have subheadings, really important. It makes it really easy for your teacher and someone maybe who is confirming your result to find the information in the correct place, okay? I would not, however, recommend that you call them stage 1, stage 2, etc., okay? I would definitely maybe use some of the language in there, like formulate or assumptions, observations as subheadings. That's fine. Solution would make a great subheading, okay? But I wouldn't necessarily use these stage 1, stage 2 kind of headings, okay? Make sure you have a reference list if you have made reference to things, okay? If you have found some information that's relevant to your assessment piece, definitely use a reference list, okay? So let's have a look at the criterion there, okay? Make sure that, here you go, you can see appropriate technical vocab, procedural vocab, conventions, and by that we mean the unwritten rules of maths. Okay, make sure you're using appropriate convention. Okay, if you can't do those things, you might see some appropriate language. Okay, that's the difference between the top level descriptor and the mid-level descriptor there. For the second dot point, you'll see coherent, which means clear, concise. We talked about that before. Appropriate to genre, you're mostly writing in the report genre for maths. Okay, make sure you have introduction, body, and conclusion, and make sure that you can read it independently of the task sheet. Okay, think of it as a maths teacher, so someone who already knows the content, should be able to pick up your report and know what you're doing. Okay, so you might need to introduce the context and not just assume that the person has read the task sheet. That would be great to put in your introduction. So that has been a brief overview of how to do a PSMT. We've looked at the format, we've looked at the 4 steps involved in the PSMT, we've looked at how to mark each of those steps, we've looked at the criterion, and we've also looked at some mid-level and high-level exemplars of a very simple version, okay? Remember, the intention there was to take away the difficulty of understanding the content and just looking at the format. Okay, so hopefully that's given you a clear picture of what to do with a PSMT. And best of luck attempting your own PSMT.